Big shout out to Packet, where I work. If you like bare metal servers, or if you don't know what they are and why they're important, go over there and check them out. Container Solutions obviously have a lot of good things to give away, as we heard from both Andrew and Pini earlier. Rensure are there in the room waiting to talk. OfferZen, CNCF, Honeycomb, Aqua Security, Kinfolk. We saw Andrew's amazing talk earlier. Giant Swarm, and then Cloud Bees. Please go and speak to them because they've all got interesting things to say and probably 3 things to give away. If you're wearing, like Adrian seems to be, an amazing costume, please make sure you tweet a photo of it to Software Circus Fun, and we will be announcing the winners of that later. Over in the other room right now, we've got Alban's Adventures in BPF Land. That's being hosted by Lee and Lee. And after that, we've got another one of our breaks, which I'm looking forward to because I haven't had a break since about 8 a.m. this morning, where we're going to have a live DJ. Very exciting. Adrian, are you back?
Yeah, sorry, I seem to, my internet has been fine all morning until this exact point.
Well, you are in Scotland, mate, and you're probably still on dial-up, so that's okay. All right, so first of all, let's kick this off properly with some canned applause. Welcoming Adrian to the stage. Adrian's going to be talking today about container registries and why we're all mad here. Adrian, please take it away.
Yeah, thanks, Mark. Right, so first off, I did call it, subtitle it, We're All Mad Here, and then I realized there was 2 other talks, also subtitled, We're All Mad Here, but this one's the only one about container registries. So, that didn't advance. So, registries have been part of the Docker ecosystem since the beginning. The Docker Hub was absolutely essential to containers going mainstream. Think about your sort of first Docker experience. When you ran Docker run Debian Echo Hello World, it wouldn't have been the same experience if you had to wait 10 minutes for the, to source and download the Debian image and install it. But in the last 5 years, registries really haven't changed much. And I think they probably should. In the modern world of sort of Kubernetes clusters, there's a lot of ways that I think registries are letting us down and can do better. And I think we can expect more from the humble registry. So in this talk, I'm going to tell a few stories and highlight some of the ways that I think registries are letting us down. And it'll also motivate why Container Solutions are building Trow. Now, Trow is our open source registry and image distribution solution. It's still in heavy development. But logo needs to change because it gives me a horrible optical illusion where I can't tell if the box is, I've been looking at the inside of a box or the outside of a box coming towards me, which I've never, so that needs to change. And actually logos will be a slight theme of this talk, unintentionally. But the main thing about Trow is that it's intended to run inside a Kubernetes cluster and integrate with the cluster itself. And that allows it to provide some extra features that aren't always found in other solutions. And the other thing is that Trow isn't focused on being a central archive for all your images in the organization going back in time forever. So it's not designed to or intended to store all your test development and production images since the year dot. Instead, it focuses on something that I've called the working set of images. And you may well use Trow alongside like another registry or a backup solution for everything else. Just to explain what I mean by working sets, the working set would be the set of images that's required to run your application on a cluster. It wouldn't be the full history of all images. So if you were given a brand new, completely empty Kubernetes cluster, what images would you need to put on it to get your application running? So that wouldn't be like old test images, it would just be the current set of images and possibly 1 or 2 generations back for rollback and so on in case of problems. So it's designed to run inside cluster. It doesn't give you a range of storage backends, which is actually an advantage because like things like Docker distribution are trying to support S3 and so on, which limits them in some of the things they can do and makes certain things like handling deletes a lot harder. And we definitely got to focus on security and auditing, which are some things that can be lacking in other registries. And it's designed to be lightweight. It's actually written in Rust, and the idea is that it shouldn't place like a burden on the cluster itself. Okay, so in the start, I'm basically going to go through a few different scenarios. And the first one we're going to look at is to do with artifact types. So the types of things that we stored in a registry. Before I get started, I did get a little bit carried away with free logo maker when I was writing this talk. So if you Google for like a logo generator, the first 4 or 5 hits will all let you create a logo free, but then they'll try and charge you 30 quid to download it. But you go to Namecheap, you can actually get one that's as good as the other ones and actually free. So anyway, imagine you're a developer at Fantastic Corp. You're working on a top secret, Fantastic Corp, I nearly forgot that. Fantastic Corp, free logo generator. I'm really quite impressed with this. So you're working at Fantastic Corp and you're writing a distributed key value store. Let's codename it Zodis. Again, Namecheap, free logo generator. I'm quite impressed with this. It's actually, I think I should have done this for Trow, to be honest. So Zodis is effectively etcd, but much faster and tailored to our use case. Now, after months of like development, testing, we finally got Zodis to the point where we're ready for the rest of the organization to see it and test it. We've run it through like all the Gypsum tests. By the way, if you haven't seen the Gypsum website, that's a great place to go and look. It gives you like a really sort of in-depth breakdowns and sort of extreme testing of distributed databases and like. So some really interesting in-depth stuff. But anyway, so we're ready to release Zodis to our organization. Now, Zodis runs on a Kubernetes cluster. It runs inside a container. So when we come to release it, what we first do is just docker push fantasticcorp.com Zodis 0.1 to upload it to our organization's Docker registry. That's more or less it. But now we come to write the announcement email. And in the email, I want to give like a one-line install instruction for Zodis. But the problem is Zodis is installed via Helm chart. And now we realize, how are we going to give them the Helm chart? We could make them clone, we could make our users clone a private GitHub repo, but that's a little bit hostile, really, and adds a little bit of extra work in. And we don't want to upload to the Helm hub because it's a private image, it's not like a public thing. And we could spend an afternoon writing our own, or not writing our own, setting up a chart repository and releasing it on that. But it'd be great if we could just release our Helm chart on our existing Docker registry with something like Helm chart push. And actually, if you think about it, there's not any really good reason that a registry, a container registry, just stores container images. In my view, and the view of a lot of other people, it should really store sort of any cluster deployment artifact that doesn't get stored in Git, if you like. So things like Helm charts, things like cloud native application bundles, possibly things like OPA files, Open Policy Agent, if you ever come across that, but also possibly things like Maven jars or NPM packages. And actually, there is already quite a lot of work on this. So the OCI registry, the OCI organization, Open Container Initiative, who do the spec for the image runtime, also do a spec for the images, and they also do the distribution spec, which is the specification for what a container registry should be, and the endpoints, etc. And they have started to define other artifact types beyond just container images. And there's also a project from Microsoft called OCI Registries of Storage, or ORAS, which again has some tooling to help you use an OCI registry to upload arbitrary artifacts. And actually already here to some extent. So like if you look at the latest release of Harbor registry, which was maybe a couple of weeks ago, they're already supporting Helm charts and CNAP bundles, as you can see from this screenshot. And then, actually, what I want to say first is Harbor probably wins the logo contest at the minute. So I really quite like the Harbor registry logo with the lighthouse. But Google haven't even tried. They need to get on the Namecheap logo generator. I'm telling you, that would make the site a lot better. But interestingly, Google have the container registry, but they're in the process of launching Artifact Registry, which is, as it says, the next generation of container registry. And as well as supporting container images, it's going to support language packages, as they say. My card just fell out. So things like Maven, Java jars, and NPM JavaScript packages. Also, Microsoft Azure has a container registry. Again, they also need to get on the Namecheap logo generator. And again, if you look down at the bottom, there's a thing, the second point is about OC artifact repository, and they explicitly call out support in Helm charts and Singularity. So Singularity, if you've not heard of it, is basically container images for HPC and other OCI artifact supported formats. So this is already something that's happening. If it's maybe not evenly distributed yet, but it is something you can do today. Also, we are going to support arbitrary image types in Trow. This isn't something I've yet tested. I did hope to talk a bit more about it today, but I've not had time. But definitely something we're going to support in Trow. Okay, so if we go back to our example, let's assume that it turns out our registry does support Helm chart, and all we've got to do is Helm chart push, and we can upload our Helm chart to registry and do a release. And everything is successful. We've got a great launch of Zodis. Okay, so that's a bit on artifact types. The next scenario I want to talk about is security and discoverability. So imagine you've been asked to do a security review of the stuff that's running in the cluster for Zodis. Now, I'm really, one thing I don't have time to talk about is like proper security tooling and vulnerability scanning, things like Aqua security and so on. I would love to get that into the presentation, but I don't have time. So I'm not going to quite go into that detail. But anyway, if you're looking at what's running in the cluster, you might reasonably start by running something like kubectl get deploy all namespaces to find all the images are running. So I've got sort of an example cluster here, something called EasyQL, something called Hello, something Redis, presumably, and Zodis, as well as the Trow registry and a bunch of kube system stuff. Obviously, this is an example. I haven't set up the namespaces or anything. And then for any of those deployments, you can dig down into the replica sets and the pods, and from the pods, you can dig down into the actual containers that are running. So we can see that this Redis pod is running the Redis image. Now that's a single word image name, so it presumably refers to the Redis official image on the Docker Hub. A bit more usefully, it also, you probably can't see my pointer. A bit more usefully, it also gives us the SHA hash of the image. So that's sometimes known as the digest. It's a content-based hash. So if the image changes at all, then that hash will change as well. So if you know the hash, you can sort of verify an image, is what it is, the provenance of an image, basically. So in this example, if I go to Docker Hub and I look at the Redis latest image, so as you probably know, if in Docker, if you don't give an image a tag, it assumes the tag latest. And we can see the Docker Hub has Redis latest, and its current SHA hash is 489E8 EAP, and that matches our hash here. So that's great. And that means I'm now pretty damn certain that our cluster is running Redis latest. But the annoying thing is, this hash, Redis latest, will change the point at a different image in a day or week or so. And at that point, if I have this hash, how can I verify that it did once point to Redis, or the Redis latest tag did once point to that hash? And there's no easy way to answer that question, and I kind of think there should be. So one thing I've done inside Trow is I've added this manifest history endpoint. So here we're getting the manifest history for Zodis 0.1 image. And you can see it gives you the history, and the topmost entry is the current, the current image that the Zodis 0.1 tag points to. Below that is the previous one, and below that is the previous one. It's the one before that. And the dates, and from the dates, you can figure out how long a given image pointed to, or a given image was referenced by this tag, etc. And I think this is really quite powerful for auditing and discovering what's going on with your cluster and what has happened, etc. And so I hope perhaps other registries will start providing similar endpoints. But you may well point out, well, the problem here is if you run Redis latest, isn't so much that you can't find the hash, it's that it's a bad idea to use mutable image tags in Kubernetes. So in Kubernetes, really the best practice is to give your images a name that always refers to a single image, if that makes sense. So to explain a bit more, when you release Zodis, or when you run Zodis in a Kubernetes cluster, you should really be using the tag, something like the top one where I've got Zodis version 0.1.2 dash followed by the git hash of the source code that was used to compile it. And that's really useful because now I can go look at an image that's in my cluster and easily go back to the source code that was used to generate it, which is great for debugging and provenance. Another option is to use something like the date and the build run number to get a unique name for my image. And that also lets me know when the image was created, which is, again, a great bit of information. Now, the other image tags are useful. Like, it's definitely useful having a Zodis latest tag and a Zodis tag with just a version. So I can, automatically update according to whatever version I want. But they're useful in different contexts. So you kind of want both. And one thing that annoys me about registries is that I wish that I could declare a given tag as being immutable. And then the registry should stop me from ever trying to point a second image at that tag or replacing that image tag. It should only ever be allowed to point to the image it was created with, if you like. And I think there's some support for Harbor, some support for immutable tags. I haven't really dug into it. But it's definitely something that I think actually should be standardized. Going on from that, one thing here is that both the git hash and the date are useful information, but we shouldn't really be just shoehorning that into the name. We want to be able to get information at any point, and what you should really be doing is using labels for your images. So here I've got I've inspected the container-sol Trow default image. And you can see I've added some labels here. I've used the open containers to image labels. So these are annotations defined in the OCI image spec. So the sort of standard metadata you can use. And hopefully the idea of using standard metadata is that tools can start to pick up on them. So for example, registries could perhaps surface them in interfaces or even allow you to search on tags or index on tags like these. And yeah, I think discoverability actually has a long way to go in registry. So I think there's a lot we can do, as I've said, so about search and listing. So being able to I should be able to give a digest to registry, and it should be able to tell me which tags have ever pointed at, or which tags have referenced that digest and when. We've seen tag history, which is the manifest command I showed you. And also we should have more stuff on image metadata, including labels. So I think that's one place that registries do let us down at the minute. Okay, on to the other image. There was a hello pod running in my cluster, or hello deployment. And if we dig into the pod, we can see it's based on this Nginx demos hello image. And if you go and look to Docker Hub and look at this image, what you'll find is that it's 3 years old and the version of Nginx has known vulnerabilities in it. So, this isn't a great thing to be running in like a production cluster. So, the next thing to do would be to remove it and to work with whoever uploaded it to get them on something more stable and more appropriate. But also, we'd probably like to just add more control over which images can run in a cluster. And one common request is just to control the images that can be run in a cluster. So you might want to say, okay, any images from our own registry can run. So in this case, I want to be able to run the Zoda's images from Fantastic Corp, or just any image from fantasticcorp.com. I also want to be able to run like maybe official images, so things like Nginx and Redis with a single name. But I don't want to allow user images from the Docker Hub. So not stuff like Nginx demo/hello. And that's the kind of thing that should be easy, but it's okay. It's not hugely complex, but it is kind of annoying to do. And the normal way to sort of control what image names can run in your cluster is to use something called the validating admission webhook. So this is something in Kubernetes. Basically, whenever you create a deployment or a daemon set or whatever, then the validating admission webhook gets a chance to look at the YAML and say, yes, it can be deployed in the cluster, or no, it can't. So in our case, what it would do is it would look at the image name and deployment YAML and say, yes, the image is allowed, or no, it's not. Now you can totally write your own validating admission webhook from scratch. You will need to create some sort of container to run the code and process the entries. But it's not hugely difficult. It's just time, and you'd have to maintain it and so on. And there are a couple of solutions that basically can implement this hook for you. So one is OPA, the Open Policy Agent. And you go on the Open Policy Agent website, basically the example it shows on the homepage does exactly this. It will let you control images on your cluster. And there's also Trow. So I've kind of baked a validating admission webhook into Trow. And if you enable that on your cluster, it will do pretty much exactly what I just said. And we can look at the config. If we just look at logs for Trow, it shows you what the current config it runs with. So by default, Trow will allow any images in the local cluster, so any images in the local registry, so any images within Trow will be allowed to run, and any, but it will deny any other images. So images from Docker Hub will be denied by default. And then you can add exceptions to that. So in this example, you can see that I've had, the default actually is to also allow anything from ka-test or gcr.io. So that's Kubernetes system images. All the Kubernetes system images are allowed to run because they start with the prefix k-test or gcr.io. I've also allowed anything with the prefix container sol Trow to allow Trow images to run. Oh, we're running out of time, Mark. Yeah, we started a bit late, so I am. Okay. I'm going to skip on. I'm going to claim that I was started late, but I will try and hurry up and save some time. So that was pretty much it for that point. I think there is a lot more we can do in security auditing, and we're working on it. The last thing I wanted to talk about was distribution. And I was going to introduce this character. Believe it or not, Jamie from CS used to be a developer. I'm going to say he wasn't a very good one. And in my story, I was going to talk about how he makes a mistake in a deployment. It takes a lot of time. Sometimes, like if you have a daemon set running, for example, to update a whole daemon set can take some time, as you tend to update images one by one, and the pools happen consecutive simultaneously. So sometimes it can be very long to update. And in my example, it actually takes 25 minutes, and 17 minutes of that is just pulling images. And those image pulls can be done a lot faster if we use something like a P2P technology. And there are a couple of existing solutions, such as Kraken from Uber and Dragonfly, originally by Alibaba, now a CNCF project, which basically do approach where you can pull from multiple nodes at the same time and vastly increase the speed at which images can be deployed. And if you can deploy images faster, then your whole organization gets faster. So it is a big advantage. And this is very much something I'm looking at with Trow. But in Trow's case, I want to make it a bit simpler, also a bit more appropriate to smaller companies. It's not just like the Ubers and Alibabas of the world. And that's definitely going to be a focus going forward. So just to sum up, in the future, expect registry support lots more artifact types. We've seen a few of those. So Helm charts, but also possibly things like jars, npm packages, etc. And we're already seeing that. better search monitoring and discoverability. So that's one thing I'm hopeful for, and I wouldn't say was necessarily here yet. Immutable tags, I'd like to be able to mark images in registries immutable and not allow people to push on top of them. And definitely advanced distribution, which I think will happen because the advantages are actually pretty great. Okay, I'll try and share these slides after, and you've got a whole bunch of links to the stuff I've talked about in this talk. Yeah, back to you, Mark, I guess.
Thanks, Adrian, and thanks for fitting so much interesting content into a slightly compressed 30 minutes there. My only question was going to be, how do people find out more? But I feel like you've covered it all here. Is Trow currently open source?
Yeah, it will always be open source, yeah. So
Okay.
you can go and try it now, yeah.
Okay, so if you want to go and check that out, you can go and run it, you can get involved. Canned applause for you. And that's it. Thank you very much, Adrian. If you want to speak to Adrian, Container Solutions have a tea room, a sponsor tea room. Hit the sponsor tab, go and drop questions in there. I'm sure somebody from Container Solutions will be able to put you in touch with Adrian to answer any questions you have about Trow. Now we have a 15-minute fun track. We have a live DJ. Go over to the fun track and listen to what is happening there. We'll see you back in this track for the second keynote of the day with Adrian Cockcroft of Amazon Web Services at 4:15 European, 3:15 me, 10:15 East Coast. I'm going to go with those maths. All right. Thank you and bye-bye.